Well, the challenge probably first and foremost is to not keep repeating what we've been doing. I think you can look over the last decade, 2 decades, and you can see our strategies to deal with emerging diseases largely is one that waits for the index case, that first human case. Hopefully we see it early, pick it up early, confirm it early, and then to try and respond to it. The problem with emerging infectious diseases is that we don't have a fully constituted toolbox. That is, if it's a known disease, we've got vaccines, we have pharmaceuticals. When it's an unknown disease, the first step once we detect it is to try and marshal a major effort to develop countermeasures. By that point, the disease continues to spread, and we find ourselves very vulnerable to its impact. You can look at Ebola, you can look at Zika, you can look at the influenza virus of 2009. So waiting for that index case as we think about the future leaves us very vulnerable. Well, I think the opportunity is, one, to recognize that for the diseases that we're concerned about, and again, virtually all of these diseases, emergent diseases that we're concerned about, have their genesis in animal populations, largely wildlife. So when we find that index case, it's really sort of the end step of an evolutionary process that's been playing itself out, if you think upstream, in the animal world. The opportunity we have is to recognize that emergent threats can be looked at, identified, understood, characterized, to be prepared for before they even fully emerge. And so the opportunity is to really pay serious attention through some very focused and strategic surveillance to identifying what future threats are circulating in animal populations, to use that information to better stratify their relative risk, and to begin using the significant increase in data about those different viruses to develop interventions that don't necessarily target an individual virus, such as a Zika virus, but you think about the family of viruses that comes from. The possibility of having examples of tens of thousands of members of the filovirus, the ability to understand cross-sectionally what those look like, allow us to think very differently about how we develop countermeasures. It allows us to ask questions in the future that we can't ask now because we're only dealing with less than 1% of what those potential agents are. So it allows us essentially, by moving upstream, identifying, collecting these data sets, really rigorously analyzing, it allows us essentially to move from what you can consider our current strategy as a whack-a-mole. I don't know if that translates, but it's basically we react to each emergence as if it's a mole jumping out of the ground. And it's enormously frustrating, enormously ineffective, and ultimately it puts the globe at great risk. I would say the opportunity to collect across the world the vast pool of viruses that are out there, document them, understand them, revolutionizes, transforms the future into one where we're far more proactive, far more prepared, and less reactive, less vulnerable. I would say that if I'm looking for a big change, it's really an attitude change. It's a vision change. It's an understanding change. It's, first off, that we're all in it together. I think Ebola should be a clear example that the period of our human history where events could occur in isolated areas of the world and stay isolated are over. We're too globally connected, and we saw with Ebola that a once remote, isolated virus, that essentially there would be outbreaks, and ultimately it would curtail itself just by essentially running into an evolutionary dead end. It would extinguish its hosts. Very rapidly now are able to get on airplanes and spread and become global events. So it's not just pandemics that we're concerned about, it's global epidemics, local events becoming global. So the biggest change is for people to understand that we have shared risk, and as a consequence, we need to have shared action.